Good morning, grade 8s. Hopefully you're on board and ready to go here. So I'm going to ask a few questions as we go, and you got to answer the question before you carry on. The first one is, whose theorem do you think we're going to look at today? Okay, tough question, right? And maybe you had some ideas, and maybe that's different to what's on the screen. And the second question is, have you ever seen or used this theorem before? Okay, and you don't have to have. So I'm interested now, of course. I'm going to carry on with the video here and you're going to see it whether you said yes or no. But that'll be interesting to see. Okay, so let me get back into my box or down to the corner a bit smaller here and look at a triangle. No, not that triangle there. Let's draw ourselves a triangle. So a triangle has 3 sides in it, right? Yeah, I think so. So I'm going to draw one like this, like that, and like that, and I'm going to make sure it's a right angle triangle with that side length 3, that one 4, and that one 5. Okay, so get your ruler out, draw to scale if you can. So my one's not perfect there, but that's fine because it's just a sketch. But draw to scale if you can. So pop in and say yes when you've drawn the triangle. Okay, so the theorem of Pythagoras, in one sense that we're going to look at it, is if we take that triangle and we draw some squares here. So this square over here, we're going to draw, which is going to have, it's a 3 by 3 square, right? So if that side length is 3, that must be 3. And we're going to draw another square out on this side, which should hopefully be a bit bigger, right? So that's going to be a 4 by 4 square. Let's put it over there. And our last square has a side length of 5. So maybe just to make sure things are going on track here, what's the side length of the other side here? Side length of other side. That is a weird way of asking that question, but it's 5. And as you can see, I've drawn a bit more of a rectangle by mistake, but it should be a square. Okay, now the key part that we're going to look at is the areas of these squares. So this bottom square, what's its area? Well, its area is 9. I shouldn't draw it in a square, that's a bit confusing. So this is 9 kind of units squared, whatever the units are. And this one on the right, I'm not going to ask because hopefully we know that that's going to be 4 times 4, which is 16 units squared. And the last one is going to have an area of 5 times 5, which is 25 units squared. So now the question is, and maybe it's just remembering if you've seen this before, but what do you notice? So maybe think how you can describe this in a few words. What do you notice about the areas of those squares? Well, one thing to notice, there might be quite a few things, but one thing that sticks out to me is that the area of this bottom square plus the area of this right-hand square equals the area of this kind of top left square over here. No, wait. You don't know where I'm pointing. So let me try and do that. If I'm over there, then that square there is equal to, wait, I need to somehow get to let's go, oh, there we go, that square up there somewhere, and then, but wait, the top, oh, there we go, that one over there equals that one. How was that? Okay, so let's have a look at another triangle. Here's one up here, and what I want us to do is we're going to draw these squares so we can picture it, but after a while, we're just going to imagine the squares and not draw them. So for the first few examples, let's draw these squares and then we'll try and work out what x is and we'll work out on our layout here. So here's a square over here, right? So that one there is an area of 16 because it's a 4 by 4 square. This one over here is 3 by 3, so it's going to have an area of 9. And the question that I have for you is, this square that I'm going to try not draw as a rectangle, but I can't really see it. I need to move over there. That's a bit better. Okay, where's the square? Over here. Okay. So the area of this square, well, it's the sum of the areas of the other 2 squares, right? So what's the area of this square over here? Well, it's 25, right? Because it's just 16 plus 9. But wait a second. We weren't asked what the square was. That was our little invention. The question is, what is x? So what is x? Well, x is just the square root, right? Because it needs to be a 5 by 5 square. So x equals 5. Now let's just capture that in what we kind of actually going to write down in our thinking. So more over, there we go, let's get in the middle. So then I can think about the diagram and what we're writing algebraically over here. So we've said that we're going to take this one here, 3 squared, and we're going to add it, let's go for this plus the area of this one, which was 4 squared. That's how we got the 16. And we said, well, that's equal to the area of this one over here. And I'm not using any big terms yet, just kind of this square over here. So that's the area of x squared. Okay, so there's our little equation that we can solve. And then however you want to solve it, we're going to develop our equation skills a bit more. But I might work this out and go, well, 3 squared is 9. And 4 squared, well, I think that was 16. That's what we worked out. And we said, well, that was equal to the area of the other side. But just to develop our equations, I'm going to call this x squared still, because that's going to line up our equation nicely. And 9 and 16, well, that's 25. So 25 is equal to x squared. Therefore, we worked out that x must have been the square root of that, which was 5. Okay, so there's kind of our layout growing on this side. We're thinking this and maybe drawing. We'll stop drawing the squares, but we're imagining the squares up here. But this is what we're writing to capture our thinking. Okay, there's one last piece of the puzzle, and that is whenever we use this theorem, we must give attribution, or in geometry, we must give our reason, and we must write out Pythagoras. That's the theorem we use, the theorem that we call the theorem of Pythagoras. Okay, got it. Ready for another example? Like you could have said, no, you're not ready. And then what? Okay, so again, here's our picture. Here's what we're imagining. So up to you how much of this you write. But we're picturing that our theorem works by having squares. So we've got a square here with an area of 25. We've got a square here on this side, which is going to turn into a bit of a wonky square, but that's fine, with an area of, what's 13 squared? Okay, well, I don't know, I'll just use one of these. Oh, no, that's a bad sub-band, don't look at that. Okay, I definitely didn't use that. I just know that 13 times 13 is 169. Okay, and this bit down here is kind of the square we're trying to work out, because that's going to help us work out what x is. Now, the green one is the biggest square. Right, it's got the biggest side over here. So the green one is the biggest square. So this now plus the 25 will give us 169. Okay, now as I said, we want to just develop our way of writing this down. So while we're thinking all of this, we're going to write down it a little bit more mathematically. So it's these two smaller sides over here that we're adding their squares to get the bigger side squared. So x is the thing we're trying to find. So that area, if we add it to, if we add it to the other smaller area, 25, but actually I just want to show 5 squared, because I want to show all of my thinking, equals the sum of, or at least the area of this square, and that one was 13 squared. Now, I said that we used a theorem, so we need to write down Pythagoras, that's the theorem we use. And now we need to solve this. Now again, you've got your own ways of solving, and we're going to develop our equations, but I'm just going to write down in this way and go, well, I know that that's 25 here, and that must equal 139. 161, we didn't use that. 169. Well, x squared plus something gives us 169. Well, that means that x squared must be, well, 169 minus 25, right? Because we've got x squared plus 25 gives us 169. So in other words, we need to subtract 25. So 169 minus 25, well, that gives us, well, what does it give us? Now, I'm at a disadvantage here in some ways. You've written something and you're going to see, maybe it matches, maybe not, but I actually wanted the answer, because now I'm scratching my head thinking, wait, what was it? I think it's 144, but I don't know. These are big numbers here. Okay, so x squared, that area is 144. So therefore, what's the side length? What is the value of x? Well, x, I'm just going to give it, you've hopefully written it down there, x is 12. Okay, so there's our thinking that we're doing. Okay, one last example coming up. Dare I ask if you're ready? No, I won't. Okay, so maybe a last question on this example is, have you seen this Pythagorean triple 5, 12, 13 before? Okay, and these are open questions because perhaps you have, perhaps you haven't. Hopefully we'll start getting a sense. 3, 4, 5, 5, 12, 13, we'll see them. We still have to do all the working anyway, so be it. Okay, so let's look at our last example. Now, for this one, I encourage you not to scribble the squares on the diagram, but to just visualize them. So what I'm visualizing is there's a square here, there's a square here, there's a square here, and we're going to use those to work out values, and there's a square here and a square here and a square here. But that's going to get quite messy with all those squares. So that's what we're picturing, but we're going to write down our working quite nicely. Now, there are two triangles. There's a triangle over there and a triangle over there. We're going to have to work our way to find out x and y. So, first question that I have for this question, a lot of questions, right? Which triangle are we going to start working in? Well, I'm going to start in triangle 1 because I think we don't have enough information in the second triangle. So maybe that would have been a better question to ask is which triangle and why? Well, I've immediately gone into the y, so sorry about that. But okay, so here here's our right angle. So that squared plus this squared gives us this 6 squared. Now we need to maybe give this a name. So this longest side of the triangle, the one that's opposite the right angle, that is called the hypotenuse. So instead of all of these thises and that's and pointing and trying to, move around the screen and move all the way up there, well, if we gave it a name, then instead of going, well, that one over, it's hard to do this upside down, but that one over there, I can rather talk about things like the hypotenuse. That's going to make life a bit easier. Okay, so in this first triangle, let's try and get our thinking down here. And that is, we've got this 4 over here, we've got the x that we're trying to find, and we've got the 6 there. So the way I always do it is just to go, I'm going to take the one side, the smaller side squared. If we add it to the other side squared, because we're picturing those squares outside, what we're going to get is the sum, or at least the square of the other one. So that sum of squares gives you that, the hypotenuse squared. And our reason for that is Pythagoras. Now, I just wonder, I always set up my equation this way, because I know I'm not going to make a mistake. It's the small side squared plus the other small side squared equals the big side squared, the hypotenuse squared. Okay, do you do it, or have you ever done it a different way? And if you have, what was that way? Okay, lots of ideas coming forward here. So let's carry on. I'm going to solve my equation. And before I do that, my question to you is, what is the value of x once you've worked this out? Okay, well, let me work it through and let's see if we get to the same or similar answers. So x squared plus 16 equals 6 squared. Well, that's 36. So the way that I'm still going to work this out is, I want x squared, well, plus 16. So I must subtract 16 from 36. Because x squared must only be 20, because 20 plus 16 gives me 36. So in other words, I must have subtracted 16 from 36. So x squared equals 20. And, well, wait a second. What square gives me 20? Well, you've already written down what you thought maybe perhaps it was. I think it's just going to be the square root of 20. Because if we remember from our squares that we've just done, the square root of 20 squared is just 20. Okay, so that's the first part. Now, because we've got that, anything we work out, I think it's useful to put in the diagram, because now we can use it in the next triangle. So, next question that I'm going to run it through is, what is the value of y? What do you get for the value of y? Okay, I'm going to carry on here. So, I've got the right angle is now over here. So the small side squared plus the small side squared equals the hypotenuse squared. So that one there is root 20. So I'm going to square that plus the other side, which I'm going to go for as this other small side, root 29, that's a 9, squared, equals, and y, what color do we want? Which I gotta ask. Okay, well, I'll go for this color here. So equals y squared. Now we're using the theorem, so we must give our reason. Notice that I've written the reason twice because I wrote it for this one and for this one. And then let's just solve our little equation. So root 20 squared, we already said we know that's 20. Plus root 29 squared, similar idea, that's 29. And that's equal to, I'm in the way here. Why didn't you tell me I was in the way? Move. Where should I move to? Let's move all the way that side. Okay, so we've got equals y squared, and so we can solve, right? So 20 plus 29 gives us 49. That's equal to y squared. So therefore y equals square root. Well, what squared is going to give us 49? In this context, 7. So therefore y is 7. Okay, well, that's it. I think that's enough examples. And it's time to do an exercise. Which exercise do you think you have to do now? Righto, well, enjoy that exercise. I'll see you, well, I might see you now, but I'll see you tomorrow in the next video. Cheers.